So we're doing section 7.5 from the Big Ideas Algebra 1 textbook. Basically, learning target today for this video, is factoring polynomials of the form x squared plus or minus, it's either plus or it's minus, one or the other, bx plus c, so in other words, a trinomial. And then we get these two types of binomials. A binomial where it's like ax squared plus or minus bx, and then we got like x squared minus a number. So we're going to deal with all three of those cases. Go ahead and write those down if you're Cornell noting it up, and we'll get going. Remember, you can pause. You can always pause, or you can go back, because I switch slides quick, because you got that control. It's a video. All right. Sorry. So, factoring. This means writing a multiplication problem. Factoring is kind of like the opposite of multiplying with respect to polynomials. You'll divide polynomials later when you talk about rational functions. Factoring will come into play there. But right now, just factoring. So he's saying, hey, this is the answer to some multiplication problem. What is that multiplication problem? When you find that multiplication problem, that is the answer to a factoring problem. So let's go ahead and do this. So looking at 15x squared minus 40x, it is a binomial, and they both have an x, at least an x in there. So what we do here is we say, hey, we can just factor something out, which is essentially just dividing out the largest common factor, the greatest common factor, like they like to say. So I look at the numbers, 15 and 40, and I say, what divides into both 15 and 40? What's a factor of each of those numbers? Well, 15 is just 5 times 3, or 15 times 1. 40's got more factors, like 4 times 10, 5 times 8, 1 times 40, all right, 2 times 20. We're like, hey, what goes into both? 5. 5 goes into both. So we're going to factor out, or divide out of 5. And then when we write this, we are writing a multiplication problem. So what we divide out is just going to come hang out on the outside. It's like the opposite of distributing. We're bringing it out instead of distributing it through. So we divide out a 5 on each one. Then we look here, we're like, hey, there's an x squared and an x. So this has x times x. This has just an x. I can divide out an x from each of them. I can't divide out an x squared because this one only has one single x. But I can divide out a 5x. So the 5x is what gets factored out. That's a terminology we use, factoring out. Like dividing out. You don't really need this line here. I'm going to get rid of it because you won't really write it on your problems. But we divide out that 5x, and then we say, hey, what goes in here? Well, what goes in there is what you get when you do that division. 15 divided by 5, that's a 3. X squared divided by x. We got two x's. We're factoring one of them out, so we got one left, so 3x. It's a minus, so what's a minus? And then here, 40 divided by 5 is 8. We have 1x. We're dividing 1x out, so it's just no more x's, right? That x is hanging out right here. So 3x minus 8 is what we get left over. The answer is it, just 5x times 3x minus 8. So 5x times 3x, you can always, sorry, don't do that multiplication yet. That's the answer. If you want to be sure that you're right, just double check. You could just multiply it through and make sure you get this. 5 times 3 is 15, x times x squared. 5 times 8 is 40, then you get the x, so 40x. So they're the same, they're equal. This is just a different way to write this polynomial. And the reason we would do this is if we had something like this equals 0. Remember, zero product property, it's really easy to solve equations when it's multiplication equals 0. It's more challenging when it's addition equal to 0. All right, so here, same idea, but just bigger numbers, variables with bigger exponents. So 24x to the third plus 42x to the fifth. We look at it and say, hey, what can we divide out of both of them? Boop, boop, boop. That's a plus. I'm just gonna put a plus there. Add. Well, 24 and 42. Well, what goes into 24? We got like 1 and 24, 2 and 12, 3 and 8, 4 and 6, right? 42, right? 7 and 4, right? 14 and 7 and 4. It's not 7 and 4. Sorry, 7 and 6. 7 and 6. I was doing the 4 from the 14. 14 and 3. Right? You figure this out. Here, I was saying it's a 6. 6 goes into both of them. 6 is the biggest number. 3 goes into both of them, but 6 is bigger, and 6 divides into both. We want the greatest common factor that we're going to divide out. So we divide out a 6 from both of them. And then we look here, we got x to the third and x to the fifth. So we're going to divide out or factor out an x to the third, because this has 3 x's multiplied, this has 3 x's, and then 2 more x's. So here we're going to factor out a 6x to the third. So what we divide out of each of them is what comes out front, as we're factoring that out. Then we actually do that division, and that stuff goes inside here. It's like the other part of the multiplication. So 24 divided by 6 is 4. X to the third divided by x to the third cancels out. Right, because it's 1. 42 divided by 6 is 7. X to the fifth divided by x to the third. We got 5 x's up here multiplied. We took away 3 of them. We have 2 left over. So 7x squared. And that's it. That's our multiplication problem. That's our factored answer. The way to check that you factored out the greatest common factor is you can look at these. 7 and 4. There's nothing that divides into both of those. They're relatively prime to each other. And there's an x squared there, and there's no x's. So there's nothing else to factor out. So that is our simplified factored form. All right, go to the next slide. Here we go. So, factoring a trinomial. There's a little bit of trickery going on here. All it is, and what we're going to do here is I'm going to show you a couple of kind of abstract examples before we jump into the numbers. So that way, when I'm working with the numbers, there's at least some baseline to like what I'm doing. So remember, factoring, this idea of factoring is writing the multiplication problem that gives you that answer. So in order to write a multiplication problem, we have to fully understand what's going on when we're multiplying these polynomials that would give us that answer. That then, when we factor, we're going to turn back into a multiplication problem. So we're going to explore this by just like looking at these products with some letters, right? Some parameters in there that these will just get replaced by numbers eventually. So if I'm going to multiply this, what I would do is just using that area diagram, say, hey, it's x plus b times x plus d. I get an x squared. Hooray! I get bx. I get dx. And I get b times d. So what this is it's x squared plus bx plus dx plus b times d. I would combine these two together to get x squared plus b plus d x plus b times d. Now it's okay if you're not writing this down. This is not necessary to like be able to do the problem. It's just good to like understand what's going on. So looking at this would be the problem that we'd be given, but we wouldn't have b times d. We'd have what this number is and what this number is. Now this number on the outside here that goes in this spot in the box is equal to the product of those two in the factor. This number right here that's being multiplied by the regular x, the x to the 1, is the sum or the addition of these two numbers, right? We got it from adding those two together. So if I have something like x squared plus 2x plus 1, and I want to factor it, I need to find two numbers that multiply to 1 and add to 2. Is basically what's going on here, because this is regular x squared. So those two numbers would be 1 and 1. So it would be x plus 1 times x plus 1. Okay, we'll do more examples later. Now let's look at this. This is a more complicated example. Notice in this one, it was just an x and an x, which is a regular x squared. It's a fairly simple factoring problem. And with these, they might kind of seem a little mysterious, but the more practice you do, if you actually practice them, they will get easier significantly. So here, I'm going to multiply an ax plus b. Here we have coefficients. And then cx plus d, and sorry, coefficients on the x's. Multiply these, right? We don't know what a, b, c, or d is, so we just got to write it out. A times c times x, b times c. Oh, whoa, that's an x squared. Yikes! X times x squared. Sorry. Here, b times c, x. A times d times x, and then b times d. All right, if we're going to add this all up, we get acx squared plus bcx plus adx plus bd. And you're like, what in the world is that, Mr. Race? That's craziness. Yeah, it is. You're not going to necessarily do this on a problem in Algebra 1. But what I want to show you is right? We can combine those like terms. BC plus AD, X plus BD. Notice, these numbers are all kind of jumbled up now. It's not as simple as just like the B and the D and the B and the D. What we have, though, is we know that there's some number, this number, yeah, so it's something plus something equals whatever this is. But this has all A, B, C's, and D's. It has all four of these numbers in there. We also would like something times something equals something. Well, in this case, we're going to say, well, the numbers, this AD and BC, the product of these two numbers, AD times BC, is just, well, it's literally just all of them multiplied together. It's just A times D times B times C. Well, that's the same as those two multiplied together. A times C times B times D. Right? There's all of them. So when we're doing something like this, I know this is a little crazy. What we're trying to do, if I have something like this, I need two numbers that add to whatever this is, and that multiply, instead of just multiplying to this, they're going to multiply to the product of these two, or the product of these two. Because the product of these two is the same as the product of those two. And we'll get to that in 7.6. I just want to show you so that when I show it later for the next video, it's not like, hey, wait a moment. We just had to multiply these. Say, what does it multiply to that? We'll get there. All right. So if you haven't fast forwarded yet, thanks. Hope it made sense. If not, don't worry about it. It's all right. We're going to do some actual examples.